Hello friends, this video on S-Block Elements Part 1 is brought to you by examfear.com. No more fear from exam. The objective of this lesson is to describe the general characteristics of alkali metals and their compounds. We'll also explain the characteristics of alkaline earth metal. Please note both are different, alkali metals and alkaline earth metals. We'll discuss this. We'll also describe the process to manufacture, properties and uses of sodium, calcium. In fact, most of the alkaline earth metals, anything which most of the important usage of alkali and alkaline earth metal. We'll also appreciate the biological significance of sodium, potassium, magnesium, calcium, right? So if you see, these two are alkali metals and these two are alkali earth metals. So the first question that comes to our mind is, what are S-block elements? So S-block elements are nothing but elements where the last electron enters the s orbital, and that's why the name comes. X-block means the last electron is an s orbital. If you see, the pink ones are the S-block elements. If you see, the S-block has hydrogen, helium, lithium, beryllium, sodium, magnesium, potassium, calcium. All these are S-block elements. All these ones which are in pink color are S-block elements. These elements and helium also, right? But in this chapter, since we've already studied a lot about hydrogen in the last chapter, we won't be focusing on hydrogen in this chapter. We'll be focusing more on alkaline earth metals. So if you see, the one in the dark pink here is the alkali metals, and the one in the light pink is the alkaline earth metals. The blue is not neither alkali metals or nor alkaline metals, but it's part of S-block elements. But we'll not discuss much about helium now. We'll be discussing more about these two groups, alkali metals and alkaline earth metals. So the next question is, why should we study S-block elements? This question we ask before any chapter, why should we study this? So here if you see, most of the detergents, it is made out of elements from the S-block element. The common salt, if you see, it's nothing but NaCl, and sodium is nothing but my alkali metal, and that is nothing but my S-block element. If you see the medicines, we use a lot of S-block elements. In the manufacture of cement, we use S-block elements. We'll discuss more about this. The plaster of Paris, the gypsum, there we use S-block. Calcium we use here. So this is a place where you use S-block elements. When you are cooking, you use baking soda to prepare pastries and all, right? Pastries, cakes. There also we use S-block elements. So S-block elements are used. In fact, in our body also, S-block elements are used a lot to maintain the balance of all the chemical compounds and for transportation of different nutrients across the body. So in biologically also, S-block elements has a huge importance, and it's good to understand these things which we use in our day-to-day life. So let's start with the properties of S-block elements. So as I have told, S-block elements consist of alkaline metals. These are my alkaline metals, the one in the pink, just in the circle here. These are my alkaline metals. And then I have alkaline earth metals, the one in the light pink. These are my alkaline earth metals. And hydrogen and helium. Hydrogen we have already studied in the last chapter. Helium will not study in this chapter, we will study later. But in this chapter we will be studying, focusing more on alkali metals and alkaline earth metals. This is alkali metal actually. Alkali metals. And apart from hydrogen and helium, if you see, most of the S-block, all the S-blocks elements are metals, but hydrogen and helium, they are not metals. So we'll start with alkali metals first. So if you see, the alkali metals I have is nothing but lithium, sodium, potassium, rubidium, cesium, and phloem. So these are my alkali metals. And this is the picture of the alkali metals just for you to visualize how things look. This is my lithium. This is how my sodium looks. This is potassium. I got all these images from Wikipedia. The rubidium and this francium is very radioactive. So these are the image of all. If you see, this is all has metallic look, right? This is stored the special container so that it should not react because it is reactive. Anyway, we will study more about these things in this chapter. So if you see, the group 1 periodic table consists of all these elements: lithium, sodium, potassium, rubidium, cesium, francium, and these are called alkali metals. Please note, only these elements 1, 2, 3, 4, 5, 6 are called alkali metals, but they are very important. As I have told, we use these metals a lot in our day-to-day life. So it's good to understand these metals, and we'll study in deep about these metals in this chapter now, right? And why they are called alkali metals? You must have wondered, right? Why alkali metals? Why not ABC metal? Why not PQR metal? Why they are called alkali metals? It is so because they form hydroxides on reaction with water, and they are strong alkaline in nature. For example, if you see sodium, if you react with water, H2O, it will form NaOH. And these hydroxides are very alkaline, they're very basic in nature. They are not acidic, they are basic in nature. And that's why they are called alkali metals. And if we talk about the abundancy, sodium and potassium are most abundant. We'll discuss about these in few slides, next slides, where we have a separate slide for abundancy of these alkali metals. And as I told, francium is very radioactive, it's highly radioactive, and the longest lived life for this isotope 223 francium is 21 minutes. Half-life is 21 minutes only. Very radioactive. And the general electronic configuration for these metals are NS1, and that's what I have told when I have discussed the atom chapter, where I have told that when you put in a group, there has to be something unique, right? So all these elements should have some unique properties, and that's why they're in one group, and that's how the periodic table is arranged, right? You put all the elements with similar the properties, electronic configurations in same group. So here you see all the elements in this group, or in the group 1. This is called group 1 actually, yeah, group 1. They have the electronic configuration of NS1, and this is how it looks: lithium, sodium, potassium, rubidium, cesium. And the same thing for alkaline earth metals. If you see, so alkaline earth metals, we have these 6 metals as part of alkaline earth metals, right? So if you see, they are all group 2 elements, and this is nothing but beryllium, magnesium, calcium, strontium, barium, and iridium. Right? Let's start with beryllium, magnesium, calcium, strontium, barium, and iridium. So if you see the structure, this is my beryllium, Be. This is my magnesium, this is my calcium, right? This is my strontium, this is my barium, and this is radium. This is how it looks actually. And they are called alkaline earth metal. Why they are called alkaline earth metal? Because their oxides and hydroxides are both alkaline in nature, plus they are found in metal oxides in earth crust. So they have this earth also added. So generally they are found in, for example, calcium is found in calcium oxide form, right? Magnesium forms MgF. So these are found in oxide form a lot in earth. So earth is also added to the name, right? Just to differentiate between alkali and alkaline earth metal, because if you see in both the cases, they give the oxides and the hydroxides of them are alkaline in nature, but there has to be a different name to differentiate. So one extra property with the alkaline earth metal is the oxides of these are found in nature, in earth crust. So they are called alkaline earth, correct? And if you talk about the abundancy, we'll again discuss this in the next few slides, but calcium and magnesiums are the most easily found metals in this group, right? And they are nothing but 5th and 6th in abundancy ratio if you talk about the earth crust. We'll talk about this in details in the next few slides. And the other ones are little rare: strontium, barium. This beryllium is very rare. It's the rarest of all, very difficult to find. And the electronic configuration in this case is NS2, right? You see the NS2. This is all about alkaline earth metals. This is just a bird eye view of alkali and alkaline earth metals. We'll discuss these things in details in the next few slides. So before we start, let's talk about the 2 different unique properties of the metals. The first is the diagonal relation. What is the diagonal relation? So it has been found that, see, typically as I told that elements in one group has similar properties. So it is expected that lithium, sodium, potassium, right, all these will have, or radium should have similar properties. Similarly, beryllium, magnesium, calcium, strontium, they should have similar property. But it is observed that lithium and magnesium have similar properties. Similarly, beryllium and aluminum have similar properties. And this is if you see a diagonal. The second element of a group 1 has similar property to third period element of group 2. Similarly, the second period element of group 2 has similar property to third period element of group 13. So this is a diagonal relation actually. And the scientists were thinking why we have diagonal relations, and they explored a lot and they have found the cause for this. And we will discuss more about a diagonal relation in the next few slides, where we'll discuss why we have a diagonal relationship, right? So let's just, this is just for introduction to tell you that this kind of property exists, where lithium, instead of having similar property with sodium, it has similar property with magnesium, and this is found experimentally, right? Experimentally they have found that the expectation was that lithium should have similar property with sodium, but it is found that instead of sodium, lithium has more similar properties with magnesium. And this type of relation is called diagonal relationship, and it is more because of the size and the charge ratio. We will discuss more about this in the next few slides, where we will discuss this in detail, right? And also please note here that this is observed mostly in second and third periods only. It is not that potassium has diagonal relation with calcium, right? That is not there. Or here if you see, you get gallium, here if you get indium. So it is not that magnesium will have diagonal relation with gallium or sodium with calcium. That is not true. It is generally with second and third period only, right? Second and third periods only. Correct? So this diagonal, please note, this diagonal relationship is generally observed in second and third period element only. So after this, it is not observed. That's why I didn't I didn't have a picture with all the elements. I had only second and third period elements. Also, one more typical behavior, or one more strange behavior they found, is the anomalous behavior of the head element. So what they have seen is the head elements have extremely different characteristics. So if you see, what is head element? If you see, these are my second period element, right? This is second period. My first period here will be hydrogen, and here will be helium, right? This is my first period. If you see the second period elements, their characteristic is totally different, and second period elements are nothing called the head elements actually. Just because the hydrogen and helium, they are one, you just ignore them. The heads are basically the second period element. Please note, the second period element, the head element, not the first period elements. And observe that they have totally different characteristics. So if I draw here lithium, sodium, here you get magnesium, you get aluminum, silicon, phosphorus, sulfur, chlorine, and here you get argon. Right? So if you see here, these lithium and sodium property will be different, barium, magnesium, properties are extremely different. And why it is different? Because of smaller size of atom. These atoms are very small in size. These groups, the second period elements, are very small in size. You have seen this, the size increase like that, right? You go down the group, the size increase in this fashion. So these are very small in size, very small in size. The second group elements are very small in size, and that's why they behave in a different manner, and they have very high ionization enthalpy. Why? Because the small size is so small, so it takes a lot of energy to pick one electron. Right? What is ionization enthalpy? Is nothing but energy required to take out an electron from the atom. Since the size is so small and the electrons are totally held by the nucleus, right? So it's very difficult to pick one electron from this atom. And we have discussed this in the atom chapter, where we discussed why the ionization enthalpy decrease and the trends of the ionization enthalpy and the size across periodic table. We discussed in the past few chapters. So if you don't understand these concepts, please, I recommend you to watch the previous videos where we have discussed the atoms and the trends in the periodic table, right? And also high electron negativity, because they want to lose one electron and become H plus, La plus, B plus. So that's why they have different properties. And the most interesting is the absence of vacant d orbitals. They don't have d orbitals here. But if you see the sodium, magnesium, they all have d orbitals. We'll discuss this when we'll discuss the structure, right? If you see the lithium structure, lithium electronic configuration is atomic number is 3, right? So it is 1s2, 2s1. You see sodium, it is 1s2, 2s2, 2p6, 3s1. So the moment it comes to 3, they have the vacant d orbitals. So 1 will have only s, 2 will have s and p orbital. The moment it comes to 3, it will have sp and d orbitals. So these guys will have d orbitals, sodium, magnesium, aluminum, silicon. But these guys, they don't have d orbitals. That is also one reason why they have totally different in the properties. So if you are having difficulties understanding sp, d orbitals and ionization enthalpy, please watch the atom video. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.